Good morning. This morning I'd like to tell you about a new category of drugs that can be used, we believe, to prevent the damage of ischemic stroke. I'm Margaret Weiss. I'm from the Department of Biomedical Sciences at Texas Tech University Health Sciences Center School of Pharmacy. First, let's talk about what stroke is. It is irreversible brain damage caused by a lack of blood flow. The major risk factor for stroke is high blood pressure. About 60% of the adult population of the U.S. over the age of 55 has high blood pressure. Of those, 10% will have a stroke in their lifetime. We believe that triacin C will reduce stroke neurologic damage, and it will do so by a novel mechanism which is not shared by any drug currently on the market. In 2008, the total cost of stroke in the United States is estimated at $65 billion. $180,000 is lifetime cost per patient for inpatient and long-term follow-up care. I included this information because I wanted you to understand that stroke is an expensive disease. The potential market for a drug that would be limiting the neurologic damage of stroke is nearly 60 million persons in the U.S. Those are the persons who are currently at risk for stroke. The comparative data that I've included here is for Plavix. It's a drug that is of a different mechanism of action from triacin C, but is sometimes used for prevention of the vascular ischemic events that precede stroke. Sales of Plavix in the United States in 2008 was $6.6 billion. As again, I include this information not because I believe that triacin C will replace Plavix, but I believe that I include this to show the size of the market of a drug that can be used to prevent the damage of stroke. Triacin C has reduced, we have data showing that triacin C reduces the neurologic damage in mouse models of stroke, and the mechanism is not shared by any other drug which is currently marketed. In our studies, we have reduced the neurologic damage, that is, the loss of brain tissue, has been reduced by 25% in the event of stroke, and we have also data showing that triacin C permits restoration of neurologic function much sooner than the untreated animals. The triacin C treated animals were sometimes able to use their right paw one day after stroke. However, the untreated animals were completely unable to use their right paw. 3 days after the stroke, our treated animals could use left and right paws with nearly equal ease, while the untreated animals still could not use both paws. This is a suggestion that the neurologic damage is reduced and that neurologic damage reduction has a translation to functional recovery. Our immediate business objective is to file an investigational new drug report with the Food and Drug Administration for triacin C or for a structurally or functionally related compound, and then to sell or license those compounds to a corporate entity. What we still need, it's about $250,000 a year for 3 to 4 years to finish our preliminary studies. We mostly need an experienced business partner. We are not business people, we are scientists. We do not understand business, we do not pretend to understand business. We need your help. We would like a strategic alliance with a small business that will allow our applications to the National Institute of Health for an SBIR grant or a similar kind of investment instrument. To date, we have progressed. Our mechanism of action studies are ongoing, and at this point, we believe they're about 50% complete. We have defined the beginning, the middle, the end. We still have a few points to connect, a few dots to connect. We have filed our provisional patent for triacin C. We have identified critical scientific team members. Okay. Our timeline for development is, we think that we need about another 12 months to complete the mechanism of action studies. Second point, we would like to synthesize triacin C and novel structurally related compounds. We think that this will probably take 12 to 24 months to get an initial estimate of what the medicinal chemical possibilities are. We want to take the mechanism of action information that we already have and which we expect to gain in the next few months to screen candidate compounds so that we are able to go to market or go to a corporation with not just a single compound but with a stable of compounds that have similar kinds of, that have a similar effect so that we can make the best choice for a drug entity. We will then, we also need to initiate our preliminary toxicity screen for our selected candidate compounds. That preliminary screen is expected to take 24 to 36 months. I can tell you in terms of toxicity right now that we have given triacin C to at least 40 mice. None of the mice have dropped dead, they haven't turned yellow, and they haven't stopped producing urine. So that we at least know that it's not acutely, horribly toxic. Our team members are myself, I'm from Texas Tech School of Pharmacy. I will be the project director. Second team members, Dr. John Stallone from the College of Veterinary Medicine at Texas A&M. John is helping on the mechanism of action studies. Our third team member is George Gokul from the University of Missouri St. Louis, and he is a medicinal chemist, a rare bird indeed. So I'm fortunate to have these gentlemen working with me, and I thank you for your attention.